Let's get a show of appreciation for Jeremy.
You're too kind. Thank you. Okie dokie. Welcome back, everybody online and people in the auditorium here. We're probably on not the most important one, but certainly the pointy end now, which is how you actually try and engender innovation and drive innovation in industry, because that's where all of this goes to. You can talk about it, but you've got to do it. So our first speaker today is Laura Field, and I had the pleasure of being with Laura at Dookie yesterday, amongst the cows and the flies. So Laura recently completed her PhD in collaboration with Animal Welfare Science Centre and Tasmanian Institute of Ag at the University of Tasmania. She is very passionate about all things dairy, and especially passionate about dairy calf welfare. Now, Laura's thesis explored potential benefits of alternative rearing systems on the long-term behavioural developments of dairy replacement heifers. So, Laura, looking forward to your report.
Okay, hi everyone. As Jeremy said, my name's Laura and I recently completed my PhD with the Animal Welfare Science Centre in collaboration with the University of Tasmania. Today, I'm going to give you a broad overview of the body of work that I developed as part of my thesis, which followed a cohort of dairy calves from 2 weeks of age until the first month of their first lactation at about 2 years of age. But before I get to the girls, I'm going to very quickly start with a brief overview of how the majority of dairy calves are reared in Australia. So Australian dairy calves are separated from their dams within 24 hours of birth to be reared by hand. Our calves are usually reared in bedded pens in sheds in small groups of around the same age and sex. Most dairy breed heifer calves will be kept by the farm as replacements for the milking herd. And these are the calves that we're going to be looking at today. They're normally weaned from milk between 6 to 10 weeks of age. And if we compare this with the natural environment in which cattle evolved, in the wild type animal, calves would normally be weaned by their dam at 9 to 11 months of age. And they would have grown up in a much more physically complex outdoor environment, surrounded by the social complexity of the herd. After weaning, replacement heifers are generally turned out onto non-irrigated pasture where they're housed until they're about 13 months old. They go through breeding and then they're back out on pasture. And they usually won't be brought back in until about 2 years of age when they calve for the first time. After calving, they join the main milking herd of mature animals for the first time. Their calf will be removed within 24 hours of birth to be reared by hand. The cow is bred again and will produce a calf the following year. And the cycle continues. So previous research has explored a plethora of ways to improve first lactation growth and productivity, but mainly in terms of nutritional factors. What the bulk of my thesis sought to explore was whether we could also manipulate the complexity of the early life environment to give the heifer even more opportunities to succeed. Specifically, I wanted to know whether increasing the physical complexity of the early life environment could improve the heifer's long-term ability to develop learning and learning abilities and behaviour, and whether improving the social complexity of the rearing environment could improve her social capabilities and reduce the negative effects of mixing with mature cows for the first time during the transition period. So to test this, in 2019, I moved across to the University of Tasmania's dairy research farm, where I reared 60 calves according to 1 of 3 treatments, with 2 groups of 10 calves per treatment. The first 2 groups of 10 calves were reared identically to the farm's commercial calves. So they were reared in groups of 10 in sheds with no mature cow contact. To explore the effects of environmental complexities, I then reared 2 groups of 10 calves, each on half a hectare of pasture with no mature cow contact. And then lastly, I reared 2 groups of 10 calves on pasture, half a hectare, with 3 dry cull cows to kind of provide a social model that wasn't giving the benefits of maternal contact, which has been studied in other research groups. And so then This will give you an idea of this is some pictures of the housing, the rearing environments for each of the calves. So these were the commercial controls that were reared in 3-sided sheds in groups of 10 to 12 with wood chip bedding. And they were weaned at around 12 weeks of age, and that's when they were moved on to pasture. My plus S and minus S calves were reared in paddocks from 2 weeks of age. Each paddock had a shelter which was split off in the plus S groups from the mature cows so that only the calves could access it. We used hessian to form a visual barrier between the plus S and minus S groups. And then after weaning at 12 weeks, the plus S and minus S heifers were mixed with the commercial control heifers and all of the other replacement heifers that weren't part of my experiment. And they were all reared at pasture together until their first calving at 24 months of age. So then I followed them all the way through until that calving. So at a few key points, the heifers underwent testing to explore certain research questions, and this timeline is going to give you an idea of the data that I was collecting. So between 2 and 13 weeks of age, I took observations on the behavioural patterns of the calves housed at pasture, so just the plus S and minus S calf. When the heifers were 18 months old, I ran some behaviour tests to look at the differences in their behaviour responses to several different stresses. When they were 23 months old, I tested their behaviour over 2 days when they were first mixed with a herd of mature cows from the wider milking herd. The data collected at these 3 points has been published and it's open access, so if you are interested in having a look, you can access them online. And then my final chapter was looking at when they calved at around 24 months of age. And I followed them daily for their first 28 days of lactation to look at their experiences during the transition period. So my first paper, I aimed to describe the behavioural patterns of calves housed at pasture with or without adult contact. Between 9:30 a.m, which was around the time of their morning milk feed, and 4:00 p.m, which was around the time of their afternoon milk feed, on a single day every fortnight for the milk feeding period, so between 2 to 13 weeks of age. I collected data on the proportion of calves in each group performing various behaviours, and the most important behaviours ended up being lying, grazing, standing and locomotion. Lying was the most commonly observed behaviour, and that tended to happen most during the middle of the day, while they tended to seem to choose to graze in the 90 minutes before their afternoon milk feed was offered. There were no treatment differences between the plus S and minus S groups, and there were no replicate differences between the two groups either. And what this tells us is that these calves seem to be performing according to these innate diurnal patterns, which we've seen in other studies in other countries where calves are reared at pasture with their dams. So it seems like that's something that's hardwired into them, is following these behavioural patterns. It's also interesting to see that when the calves were given the opportunity to graze, they did choose to interact with the pasture that they were housed on. So then moving on to my second study, in which I tested the effect of early life treatment on heifer responses to a series of stresses. This was in 3 behavioural tests, so restraint in a crush, 7 minutes of isolation in an arena, and then 7 minutes with a novel object in the same arena. And the novel object was this rainbow umbrella that you can see up here. I video recorded these tests and then I coded the behaviours from those videos. And I found that there was no treatment effect on heifer responses to restraint or isolation. But interestingly, there were differences when the heifers were presented with novelty. So of the 49 heifers that I tested here, 7 animals interacted with the umbrella, and 6 of them were from the plus S group. On the other hand, the CC heifers spent about 50% more time in vigilance behaviour, which you can see just here, kind of head up, looking at what was going on with the novelty. And what was interesting as well is that the minus S heifers, so those reared at pasture without adult contact, were kind of in the middle. They didn't interact with the novel object, but they also didn't show this vigilance behaviour. They were very similar to the plus S heifers in that regard. So what we kind of concluded from this is that both early life physical and social complexity played mediating roles in reducing the fearfulness of novelty, and it may or may not have had a cumulative effect. This told us that early life complexity can influence the behavioural responses of dairy heifers to novelty even up to 18 months later, and this isn't something that's really been explored so far globally. So then I wanted to look at whether the social modelling that was provided by the mature cows during early life had any social benefits for the heifers when they started to experience a bit more social stress. So when they were 23 months old, I did some integration testing to see if there were treatment differences in how the experimental heifers behaved when they were first mixed into a group of mature cows. I'm going to be super brief on the methodology because it's a bit much, but basically they were tested in a total of 6 groups, and each group was tested over one of 2 weekends over the 2 days of the weekend. On day 1, a mixed treatment group of heifers was introduced to a group of mature cows that were resident in an allocation of fresh pasture at a ratio of 2 cows per heifer. On day 2, this now mixed group was moved onto a fresh allocation of pasture. And we recorded a few things. So we recorded behaviour during the first hour after mixing on day 1 and the first hour after movement to a fresh allocation of pasture on day 2. We also collected grazing, rumination, walking, lying and standing behaviour using automatic warn technology, and that was for the full 48 hours. And we found a few interesting effects. So firstly, we found that when heifers are mixed with mature cows at pasture, and this is something that has been seen in house systems, but not so much on pasture, they do receive significantly more aggression from cows than they deliver to cows. And that's to be expected. They're kind of the larger, older cows tend to try and dominate the younger, smaller animals, and that's seen across systems. We also found that the heifers housed at pasture, so the plus S and minus S heifers, displayed more aggression towards other heifers than the CC heifers did. This indicated to us that the agonistic behaviour of heifers reared at pasture towards other heifers perhaps suggests that these animals are more dominant or have more dominance behaviours kind of ingrained in them. Then on day 2, we collected data from our warn technology, and we saw that plus S heifers spend an almost identical amount of time grazing as the mature cows, but the minus S and CC heifers spent more time grazing than the mature cows and the plus S heifers, and much less time ruminating than the mature cows. And we thought this probably has to do with dominance as well. The ability of the plus S heifers to integrate into that group by the 2nd day of mixing, but the minus S and CC heifers were most likely being displaced from their grazing areas, and they weren't able to reach room and fill as efficiently as the plus S heifers. So this kind of told us that there's some evidence that social complexity in early life does improve their social abilities up to 23 months later. And then for the final chapter of my thesis, I took data from my heifers for the first 28 days of their first lactation. One of the key reasons that I followed my heifers all the way through was that I wanted to see if there was going to be a productivity effect of this early life complexity that would have an economic benefit to producers. So in previous dairy cattle research, stress has been associated with reductions in milk yield and body condition, and increases in indicators of physiological stress such as cortisol in the milk. For a heifer, her first calving can be one of the most stressful periods of her life. Socially, she's separated from her calf and from her resident group of heifers that she's been reared with, and she's regrouped into a group of unfamiliar mature cows that, as we've seen, can be much more dominant towards her and suddenly be receiving all of this aggression from these bigger, older animals that she's never met before. And in terms of the physical stresses that she faces, she's going through the physical demand of suddenly entering into lactation and producing milk. She's having to deal with a novel milking environment, the milking routine and increased handling associated with being brought to and brought from the parlour. This is a lot for an animal to take in a very short amount of time. So we thought, based on the results of our previous studies, the plus S heifers seem to be more socially competent and seem to feel less stress or be able to acclimatise to that older group of animals more easily. So they may have less stress experienced at entry to the herd of mature cows. And we also saw that the plus S and minus S heifers seem to be less fearful of novelty than the CC heifers, and so they may be less stressed when they had to start to face the novel factors, including the milking environment and the new routine. So then we started to look into this. So to measure it, I took data across the full 28 days of each experimental heifer's lactation. So to look for physiological differences in stress responses, I decided to look at milk cortisol concentrations at 3 key points. So at day 7, when most heifers first moved into the main milking herd, at day 14, when they'd been in the milking herd for about a week, and then at day 28, when they'd been in the milking herd for about 3 weeks. Our milking system automatically recorded the weights and body condition scores of our milking herd daily, as well as milk yield and the position in the milking order. And the position in the milking order tends to be fairly stable once it's been established, usually within 6 days of lactation. Animals will tend to stay there, and there's some evidence, but it's not fully proven, that more dominant animals will choose to be towards the front of the milking order. So using all of this automatically collected data, I also looked for differences in milk yield, average daily gain and body condition scores, position in the milking order once they entered the main herd. And I didn't find any direct effect of treatment on any of the productivity measures. But when you look at them as a cohort, they followed a normal lactation curve with associated body condition loss. So their milk yield went up, and their body condition went down, and so did their body weight. But the magnitude of this loss did slow down as they reached 28 days, which suggested they were starting to move out of their negative energy balance at that point. What was interesting is that their milk cortisol was significantly higher at 14 days, so a week after they entered the milking herd, than at 28 days, which suggests to us that that first week of mixing was probably the most stressful for them. It can be associated with the physiological stress of ramping up lactation, but normally you'll reach peak production at 4 to 8 weeks. So that doesn't seem like that timeline's fully matching up to us. And in terms of milking order, there was no direct treatment effect on position in the milking order. The heifers were, in general, were most likely to be in the middle 50%. And the CC heifers tended to settle into their milking order position faster than the other 2 treatment groups. And we need to do a lot more research into this, but we think this is something to do with behavioural flexibility, where the CC heifers may have been less flexible based on previous research that says lower complexity equals lower behavioural flexibility. We think possibly they settled into their routine, and that's what was going on. So that was my thesis. It was exciting to follow this group of heifers from birth until 2 years of age, because no one has really done that, especially in a pasture-based system. And to see that there were treatment effects along that whole period was a very exciting thing to be a part of. We found that increased complexity in early life appears to make it easier for heifers to deal with novelty, easier for them to integrate into groups of mature cows as first calving heifers, and it shows some early evidence of increased behavioural flexibility. The combination of social and environmental complexity seem to have the biggest effect for those heifers. But what we need to do now is further research, especially on those productivity measures that need large cohorts to understand treatment differences that have all of those different factors feeding into them. So we need to be able to replicate these findings and also understand productivity implications of this so that we can apply this to a farming system in real life, not just in an experiment. Thank you very much.
Next up, we have Amelia Sofra. Amelia's just completed her honours project in the Bachelor of Science programme here at Melbourne. And she was looking at piglet welfare in a free-range housing system over winter. So, Amelia, please.
Thank you, Jeremy. Okay, so good afternoon, everyone. My name is Amelia, and today I will be presenting a snapshot of my honours project, which focused on examining links between temperature, piglet behaviour and survival during winter in free-range housing in Australia. So free-range pigs are those who are housed outside for their entire production cycle with unrestricted access to shelter, and this allows pigs to perform their natural repertoire of highly motivated behaviours. So the farrowing and lactation stage is the period just before parturition up until weaning of piglets, and in this stage sows farrow in individual huts and have access to group paddocks. So in free-range systems, cold stress is a welfare concern that affects piglets. Piglets in their first 4 days of life have a high thermoneutral zone and limited ability to regulate their body temperature. So as a result, they rely heavily on behavioural adaptations to maintain warmth, and specifically by huddling close to the sow, which allows piglets to gain warmth through conduction. However, proximity to the sow is also a major risk factor that may lead to increased overlays. So the aim of this project was to examine the impact of cold weather on piglet welfare by looking at whether cold temperature is predictive of piglet proximity to the sow and the effect of this on overlays and survival. So the study was conducted on a commercial free-range farm over winter, and 200,000 their litters were observed over the first 4 days of life. And both in-person and video behavioural observations were collected, and piglets were recorded as either resting or awake at udder, and proximity to the sow was quantified, as you can see here. A temperature logger was also placed in each hut. So for the sake of time today, only piglets in contact with the sow will be discussed. And we saw that when piglets were resting, they were significantly less likely to be in contact with the sow as hut temperature increased during observations on day 1 and 3 and trending in the same direction on day 2. And this was expected as there is less need to huddle close to the sow as it gets warmer. There were also a subsequent effect of average hut temperature over the first 4 days on the total number of overlays over lactation. And overlays made up about 72% of total deaths during lactation, which is a similar statistic to prior literature. So what this tells us is that as it gets colder, more piglets get overlain and die. However, there were no significant relationships between total overlays during lactation and sow piglet proximity over the first 4 days of life. So therefore, while decreased hut temperature does lead to both increased overlays and sow piglet proximity, these two don't appear to be linked. So increased overlays may therefore occur due to chilling, where piglets get so cold that they can't avoid overlay by the sow. As temperature increases, the odds of piglets shivering also decreases. So the research shows us that piglets do get too cold during winter, even in a more moderate Australian climate. And this leads to piglets spending more time in close proximity and to more overlays and deaths. So therefore, behavioural signs of this inability to cope, such as shivering, may provide stock people with important information on when intervention may be required. Thank you very much.
Thank you, Amelia. And it's pigs again, thank goodness. I do like pigs. And this is Megan is going to be talking about, Megan's a research fellow here at Melbourne University. She studies effect of housing husbandry on pig welfare. And Megan's been talking about thermal stress or reducing thermal stress in free-range pigs.
Thank you very much, Jeremy. I'm excited to continue on from Amelia's fantastic presentation and keep talking to you today about thermal comfort in free-range pig production systems. So Amelia's introduced us a little bit to free-range production. So this is where pigs are born and reared outside. And this kind of housing comes with a lot of animal welfare advantages because pigs have opportunities to display highly motivated natural behaviours that we know are important for their welfare. However, this kind of outdoor housing also comes with unique welfare challenges, and one of these challenges is coping with harsh climatic conditions. Now, in Australia, the land of the sunburnt country, we, of course, are interested in the impact of hot weather on pigs, and we know that that has some welfare effects in free range. But what's often overlooked is the impact of cold weather on animals. And as we've sort of started to hear about from Amelia's research, piglets are the ones that are most at risk in cold weather because they have a very limited capacity to thermoregulate. Now, in free-range production, the land use needs to be rotated very regularly, and deep straw bedding is used in farrowing paddocks where piglets are born. And this kind of management requires that the housing systems used for pigs are robust enough to withstand really regular moving. And because of this, we see that these simple shelters are used. Now, there is a lot of different designs, but they can look something like this. And these simple shelters, one of the issues with them is that we don't believe they always offer newborn piglets with optimal protection for the climate, particularly during winter. Now, we see from international research, but also from our own research here, as presented in the previous talk, that there is this link between weather and piglet survival, whereby piglets are at a greater risk of dying when their shelter is colder. Now, we can't control the external weather, but what we can control potentially is the microclimate inside their shelters. And so what we wanted to know was, can we increase hut temperature using a really simple, cost-effective and readily adoptable intervention? And we were interested in knowing how this affected thermal comfort in the piglet, and of course, interested most importantly in how this affects the production outcome of piglet survival, production and welfare outcome, I should say. The intervention that we used to increase hut temperature was a really simple, transparent rubber door covering over the entryway of the hut. It was designed to reduce heat loss from the hut and reduce the overall daily fluctuation in temperature as well. And it covered around 3/4 of the doorway to still allow a little bit of airflow at the bottom. We studied 200 litters of pigs in Victoria, Australia, and they were housed in group paddocks of 8 litters or 8 huts each. And we used a randomised complete block design to assign the door flap treatment to positions within the paddock. And we studied these pigs over 6 time replicates, with piglets being born from early winter to early spring of this year. We placed a temperature logger inside every hut that collected temperature data every hour, and a number of these loggers also collected humidity data. But in addition, we were interested in understanding the temperature of the available lying area for piglets. So once a day early in life, we also collected the temperature of the straw bedding for where piglets sleep. Additionally, we were interested in whether the door flap would have any negative effects on the microclimate of the hut as a result of reduced airflow. So we also recorded hut ammonia concentrations once a day and looked at the moisture content in the bedding once a day early in life. We also looked at piglet behaviour, and today I'll talk about shivering and huddling behaviour. So we were interested in shivering, which is an indication of thermoregulatory behaviour, and huddling, which is here we were looking at whether the litter was huddling in one group and seeking contact from one another to gain warmth, or whether they were resting in more than one group. And of course, our key outcome was piglet survival. So we looked at the timing and causes of mortality from birth until weaning. Now, in this kind of system, within the first 24 hours of life, which we call day 0 here, just for consistency, at day 0, piglets are fostered between litters to equalise the number of piglets in the litter, and also to equalise the size of piglets in the litter. And today I'm going to talk about piglet survival that took place after that processing, or after that fostering took place, until 12 days of age. And this is the period where we see quite a lot of mortalities. And those hut climate and piglet behaviour measurements were taken daily from 0 to 4 days of age, and that's what I'll report on today. So starting off looking at temperature, we found that our door flap treatment was very effective at increasing the hut temperature. So here we've got daily maximum temperature and daily minimum temperature plotted with the split by treatment. So if we have a look at daily minimum temperature, in the control huts, the daily minimum temp was estimated to be around 9 degrees in control huts, whereas in our door flap huts, it was estimated to be 2.5 degrees warmer than that. It is also important to note that we actually had a number of huts where the daily minimum temperature was 0 or below 0, so it was getting quite cold. When we look at the difference between minimum and maximum temperature, we also saw that there was less fluctuation in daily temperature in the door flap huts. The effect on straw temperature, so the temperature of the available lying area for piglets, followed the same direction, where it was warmer in the door flap huts. And of note here was that even though the temperature of the bedding in door flap huts was warmer than in control huts, it was still actually quite cold. So we see in control huts, for instance, the temperature of the straw, even though this was measured at one of the warmer parts of the day, was only 12 degrees in winter. When we look at hut humidity concentrations, straw moisture concentrations, and ammonia concentration, there was no effect of our treatment. And in this instance, no effect of our treatment is actually great news, because this is telling us that our door flap treatment had no negative effects on the microclimate of the hut. When we look at whether the treatment affected thermoregulatory behaviour, we saw that there was an impact on shivering behaviour. So piglets in door flap huts were less likely to shiver compared to piglets in control huts across all days early in life. And unsurprisingly, we also found that shivering reduced with age as piglets grew bigger and were better able to thermoregulate. However, there was no effect of our door flap treatment on the thermoregulatory behaviour of huddling behaviour. Now, onto the interesting and important stuff, survival. So we know that our door flap treatment is having a small but impactful effect on increasing hut temperature, but does this translate to improved piglet survival? Now, if you're not familiar with survival curves here, on the y-axis, we have the proportion of piglets that are alive. So at the top, you can see it starts with 100% of pigs being alive. And along the x-axis, we have day of age. And here we're just talking about mortality after fostering, so within the first 24 hours of life until 12 days of age. So every time we see a drop in the curve here, it's indicating that piglets are dying. and the steeper the curve, the faster the rate of death. So what we saw was that there was quite a significant effect of our door flap treatment on piglet survival, whereby piglets in those door flap huts had a lower rate of mortality from 0 to 12 days of age. So at around 12 days of age, the number of piglets alive in door flap huts from post-fostering was estimated to be around 90%, where it was around 85% in our control huts. Perhaps not surprising, but I think quite important and important for us to be aware of was that there was also an effect of the litter's weight category. So when fostering took place early in life, the litter was categorised as being small, medium or large in terms of the size of piglets. And we found that litters that were categorised as small actually died at over twice the rate of medium and large piglets, which is telling us that they probably need a lot more attention, particularly early in life, where we can see that the drop in this curve is really quite steep. So together, our research, in terms of Amelia's research and my own, is showing us that piglets get cold, even in Australia in winter. But we can actually use really simple, pretty cost-effective interventions to address this and have an awesome effect on piglet welfare and production outcomes by improving survival. And importantly, we can do this without having any negative effects on the microclimate of the hut too. Now, our next steps in terms of this research are really around understanding when door flaps need to be put on and when they need to be taken off. These door flaps aren't designed to be on the huts year round because it would get too hot for the sows. So we need to sort of understand what the optimal temperature or time of the year is for them to go off and then for them to go on and then come back off so that we can try and find a balance between the sows and the piglets' thermal needs. Thank you very much. I'd like to acknowledge my wonderful research support team, Lucy, Jess and Amelia, who collected a lot of this data over winter on farm this year. And I'd also like to pay thanks to the Pastoral Pork Company and in particular Ian, who's with us here today, and Joel and Hayden and the wider team at Pastoral Pork who facilitated this research. Thank you.
Great presentation. Thanks, Megan. And now I think it's the final presentation. This presentation is by Rutu Galea. And Rutu is a PhD candidate at the University of Melbourne, working intensively on the TAILS project, which is looking at trying to find answers and strategies to minimise or eliminate tail biting within intensive pig production. So Rutu, if you'd like to come up. Thank you.
Thank you for the introduction, Jeremy, and thank you everyone for staying till the end. I'm going to continue talking about thermal comfort in pigs, following on from Amelia and Megan's talk, but this time in relation to intensively housed grow-out sheds. And we were interested to see if we're seeing any seasonal changes in tail biting in pig production in Australia. So for those of you who are not familiar with tail biting behaviour in pigs, it is an oral manipulation of pig's tail by another pig, causing a varying degree of tissue damage. So if you follow the pig at the back, you can see it manipulating the tail of another pig and you can see some tissue damage. So yeah, it can go on for a while. It is very stressful for the victim of tail biting behaviour, as you can imagine. It is also generally accepted that the biters have compromised welfare state. It's stressful for stock people who have to manage tail biting outbreak, and also economic loss for the producers, because in a lot of the cases where the damage is severe, the carcass needs to be condemned at abattoir. So what can we do about it? So we have two options. We either prevent tail biting by performing tail docking or providing enrichment. In most cases, straw is the most recommended enrichment, or we manage the myriads of risk factors that are at play here. So most commonly used practice is tail docking. And this is also routinely performed in Australia, in the intensively housed pigs in Australia. And But if we want to go remove the use of tail docking and move on to managing risk factors, how can we do that? So if you look at the literature, we've known and talked about tail biting since the early 60s. There was a steady increase in literature on tail biting around 2000s, which led to the European Union to ban the routine use of tail docking, which then again there was an increase in research, which led again to European Union to have a recommendation to manage all the risk factors. So that's where we are at. We ban routine use of tail docking and manage risk factors, but it is very vague. So it's the same in Australia. We don't recommend using tail docking as a routine practice. However, in most cases, tail docking is still performed. So how do we look at the risk factors? Well, most of these studies are performed on experimental conditions. They were of this scoping review that we did, of the 511 studies, there were only 4 epidemiological studies, none of them done in Australia. So why do we need a unique study in Australia? There is a lot of research that is done on tail biting, mainly in Europe and America, but Australia is different. Our climate is different. As you can see in this graph here, like we are in a different climatic zone in Australia. Our pig production systems are different. We have varying group sizes, we have varying herd sizes. We also have a unique opportunity here where our pigs are born and go through each stages of production in one site. So we can look at these influences, early life experiences, early life factors, and how they would impact tail biting later on in life. So we have this unique advantage, and we cannot just rely on the European literature. So we are doing this study in Australia. So the aim of my PhD is to look at the risk factors for tail biting in Australia. And as you can see, we are doing this in commercial conditions, and there can be any number of these factors that can influence tail biting. So we are looking at everything. But for the purpose of this talk, I'm just going to focus on the climatic factors. So just to give you a brief overview of our methodology, we collected data from 8 sites across 4 different states in Australia. And like I mentioned, we are in different climatic zones here. So we wanted to have all those information captured in our data set. So we collected data from 79,552 individual pigs. These were pigs with docked tails, and we followed them from birth to slaughter. And we did the data collection over a 23-month period from January 2022 to December 2023. And so this is, like I mentioned, an epidemiological study. And in total, we have 76 variables that we've got information from. And so the main thing we wanted to do is, obviously, we were expecting a large amount of data to be collected on farm, but we wanted to try and keep the outcome of interest as simple as possible for all the producers to collect reliably. So our case definition for tail biting injury was very simple: 1 with no injury, 2 with minor lesions, and 3 with deep lesions. And so this 3-point scale was used to assess tail biting injury from weaning until the end. So every time the technical officers on ground found tail biting, they would record that, and then they would mark the pig and follow them through until they are healed or the damage becomes more severe and they have to be moved. So like I said before, this is a big study. We're collecting large amount of data, but my focus of this talk is only climatic factors. So I'm only going to talk to you about how we did that. So we collected climatic variables at 2 levels, at site and the shed level. So we had weather stations at each of the sites because some of our sites were quite remote. So we had put special weather stations there. And we had these temperature and humidity loggers in each of the sheds that were in our study. And so they measured the humidity and temperature every day for every hour for 24 hours. And so just to give you a brief overview of what we saw in our data set. So there is a huge difference in tail biting across all our sites. So starting from 0.1% to almost 10% tail biting incidents that we see in our sites. And when we look at the age at which the tail biting happens, so these are, again, to remind you, these are pigs with docked tail. So in a lot of the literature that you see coming out of Europe, that they are pigs with intact tail and they see tail biting happening quite early, whereas we see tail biting progressively increasing from grower to finisher period. And now when we look at the climatic factors, so we wanted to see what the outside temperature and humidity, how that affects tail biting in the shed. So this is the outside climatic variable, so collected through using the weather station. And so in the blue is the temperature, daily average temperature, and in the pink is the daily average humidity. And so if you look at the density of events, we can see broken down by season. We can see that in spring and in summer, we are quite good at keeping the sites are quite within the thermoneutral zone. Whereas in the winter and in autumn and winter, our sites are quite low, go below their thermal comfort zone. And so we wanted to see how this translates into what is happening inside the shed. So like I said, you know, the pigs, these are older pigs, so their thermal neutral zone is between 15 to 30 degrees Celsius, and the recommended humidity is 40 to 60% in the shed. And so in spring and summer, we are good at managing our sheds, whereas in winter, we have quite a lot of period where the daily temperature is below their thermal neutral zone, and the humidity is quite high in the shed. And if we see how that affects tail biting, we see, you can see again in the temperature, there is quite a lot of tail biting when the pig's shed temperature is below their thermal neutral zone, and a lot of tail biting when the humidity is higher than their recommended range. So what does this mean? Well, again, 60% of tail biting events were recorded in autumn and winter period in our data set. So the take-home message is we see high incidence of tail biting during autumn and winter. And, you know, we do a very good job of managing our sheds during summer and hotter months, but we need to improve our facilities to manage cold and humid seasonal changes. And thank you to the entire tail biting team.
Great, thank you very much indeed, Rutu, for that. That was terrific. I'm sure it's got a lot of questions. We do have one more Menti, I believe, so we'll have a look at that before we get on to the questions. Is it just one slide this time? Two slides this time. So your first question out there is, what do you think is the single biggest barrier to positive animal welfare change? So if you could all have a think about that, that'd be great.
This might be skewed by the fact that we had a lot of researchers when we asked where are you from.
I think so too, as well.
It was me that time.
Okay, so it's funding and resistance from industry. Not all industries, I wouldn't say, but certainly perhaps some industry. Okay, next one, thanks. And the last question before we get on to questions is, what are the biggest challenges, if you put them in order if you can, to trialling new practices in industry? Because we're talking about the innovation implementation side of things here. So where would you put them? Are we expecting that to change?
Yep. Where would you put them?
from an industry hat on, I would say, it's changed, the brown one, actually accessing people who are expert enough to help you in your endeavours to improve welfare in industry.
They can email us.
Aren't you part of a scientific collaboration to collaborate with?
I have many hats. I'll put the other hat on in a minute. So funding cost, concerns about, yes, impacts on production if we start doing work in a production facility, which I guess you talk about, then there's lack of research facilities. You know, we used to have a lot of good research facilities in Victoria for pigs and poultry especially, but they're not there anymore. Resistance from management, not enough research for information, no connections, concerns about the negative welfare impacts, I suppose, of impositions that researchers might want to put in place. Concerns about biosecurity impacts as well, certainly. Yep. And other. Other would be anything important in the other? If there is, let us know. If there isn't, we'll just leave it about other. Okay, thank you very much. Okay, now can we ask the panellists to come up and we'll see if we can get some questions from the floor, and then also we got questions online. One question online so far? Thanks. All right, Mia, well, if you could perhaps ask the question from online first.
Sure, I think it was posted after Megan's talk, but perhaps Rutu could chat too, although it does say in regards to outdoor piglets. Would you also be looking at effects of increased temperature and heat waves on the sow and whether there are negative outcomes on production?
So it's not something that we did this year. We were only focused on cold temperature because it's quite a knowledge gap, but certainly there are some great people, especially from the University of Melbourne, who are looking at that in this space. Yeah. And we know that heat stress is more of a welfare issue for the sow, whereas cold stress is more of a welfare issue for the piglets.
Any other questions online?
Not at the moment.
Any questions from the room? Yes.
I'm not Megan. What do you think the cost of implementing those flaps would be?
Yeah, thanks, Maddie. I forgot to bring it with me because I knew if I threw in that thing about it being a cost-effective adoption, someone would ask me. And I actually have it written down, but I don't have it, so I'm sorry. I can find it.
That's okay.
Yeah.
Oh, actually, but do you think it would be a barrier? Do you think it's something that these changes?
So is the cost a barrier? I think if we're weighing up the positive effects on piglets alive, then no.
I've got a question about this, Megan, as well, about this provision of straw.
Yes.
Would you say, have you been to other outdoor farrowing farms, or is this the only one?
This is, yeah.
And my question would be, is this farm skimpy
Oh, in terms of straw?
in terms of straw compared to other farms?
So straw provision is required as part of free range certification.
Yes.
So straw is used across all free range farms. Interestingly, we did see that anecdotally we found there was some variation in the quantity of straw that was provided prior to farrowing. And so as soon as we noticed that, we started taking as much data as we could on how much straw was provided because we thought that it might be have an impact on piglet survival.
Yeah.
So when there's not enough straw, there there's thoughts around that increasing overlays, but also when there's too much straw, the piglets get buried underneath and they don't have the ability to escape the sow and avoid overlay. So we started just recording whether the straw amount was normal, low or high based off just visual inspection, but using that very scientific scoring method, we didn't see that it had any impact on piglet survival or overlays at all. But we certainly see variability.
And what about the mortality before fostering? Because you're missing a whole day there.
Yes, yeah. So we didn't see any effect of the door flap treatment or of temperature on day zero survival.
Day zero went in the opposite direction.
Okay, we might need to come back to that. But there was no effect of the door flap treatment on the number of mortalities that occurred within the first 24 hours of life.
Right.
So from birth until that fostering took place, there was no effect of the treatment there.
Thank you. Cheers. Mia?
This is a question for Laura. Laura, can calves get some of the benefits that are associated with dam rearing from a non-maternal adult cow as a social partner?
Yes, so that was kind of what I was looking at. Most of the research with cow-calf contact until the last 2 years has been in indoor systems. And also most of the research looking at non-maternal contact. At the moment, the research is focused on feeding behaviour, and it does look like even if you mix your young stock with a more experienced older animal, they will have a faster uptake of novel food. And they will explore novel areas, but that effect only seems to last 2 or 3 days. So I think, yeah, there's a lot of research to be done in the area, especially looking at the social implications of it. We don't really understand that at all. But dam, and even the longitudinal studies on dam rearing, there's not so many. I think there's 4 or 5 publications that have gone beyond weaning, and they've all had positive social effects. So we first need to understand the positive social effects on the calf with dam rearing, and then we can look at the positive social effects of non-maternal adult contact.
Thanks. Any other questions in the room? Maddie?
Yeah, I have a lot for Laura. Do you think, how practical do you think nanny cows could be in the dairy industry?
I think it was interesting. The first study that I didn't talk about here was a survey of producers in Australia, and I was kind of trying to see if there were certain management practices that farmers were doing with their calves that were linked to demographic factors or even regional factors. And there's just such a broad range of the way that people are managing their animals. There's not so many staff members on dairy farms, so they're kind of their own unique cultures. So I think it's practical for some people, and I think if people were looking to transition to a cow-calf system but weren't ready to commit to keeping the calves on the cows, it's a practical option if you're willing to invest in the infrastructure. But that, I think, then relies on the attitudes of the individual producer to make those changes. I did a little bit of a literature review into the value of cull cow carcasses. And if you do feed them on after they've been dried off and kind of bring up their body condition, they do have a fairly valuable carcass in some markets. So it does have the potential. Right now, you'd not be making a lot of money by doing it. But especially in Tasmania, there's quite a few people who do rear their calves outdoors from 1 or 2 weeks of age. And this could be a way that you could, with proper disease mitigation strategies, be kind of giving these calves a bit more of an oomph as they grow up. Yeah.
Any other? I've got one for Rutu. When you were training the people to do the tail storing, did you look at the interrogative reliability? Because 2 and 3 could be missed.
Yeah, we did.
You did?
Yeah.
And it was okay?
Yes.
Good.
Thank you.
Peter?
Thank you. Amazing presentations. Another great session. My question is for Amelia. You talked about shivering behaviour. Can you explain to a chook person why that's important behaviour, and is it something that we should be monitoring more closely?
Yeah, so piglets have very limited thermoregulatory capacities because they don't have any brown adipose tissue, and they just don't really have any energy reserves when they're first born because they're so little. So shivering is a really important thermogenic adaptation that they have, and so we often see it when they're all huddled together in groups. And so while it's probably something that is like a thermoregulatory, it may also be an indicator of a struggling to cope, particularly when combined with like other behavioural adaptations such as things like huddling, and there's some research into like postures as well. So I think altogether when you look at it, it may not necessarily be indicative of a huge problem of itself, but maybe good for stock people to be able to recognise and be aware of and monitor. Yeah.
Amazing. Do it with AI and then put the stuff up when you get the detection.
Yep.
Better put some politics into the discussion. So thanks to Lauren and Megan. 2.5 years ago, I rounded up all the free-range production units in Australia, or major ones, and convinced Lauren to do a research submission to the industry. We pay about $100,000 a year in a research levy. That's just our company. And unfortunately, we didn't get industry support. We were actually prepared to put more money in on top of the $100,000. And luckily, I'm not too sure how it happened. I rang again and Megan told me she'd applied for a Melbourne University postdoc.
This project was funded through April, so we did have a little bit of industry support as well. We should mention that in case we've got some wonderful industry partners joining online, in addition to yourself.
Sorry, I wasn't aware of all that.
It was also largely funded by an early career researcher grant at the University of Melbourne.
Right, that's where I was wanting to get.
Yes.
So thank you very much to Melbourne University for actually doing that contribution and actually allowing the research to happen. As I said, hopefully we'll generate some more projects. And certainly I think it's good for your honours students, given that we're only just down the road, so you can access a lot of pigs, a lot of farrowings very easily. Thank you.
Thanks, Ian. And I think there was one other one online.
Yeah, there's a couple. Pigs again. Question asking, the farms that were studied specifically for the door flaps project, do they put other temperature control methods into place, such as the positioning of the huts? And this person said they knew of a farm that would face their huts towards the wind in summer and away from the wind in winter, for instance. So is that sort of considered and controlled for?
Yes, this farm also has the same practices where the huts are rotated depending on time of year to let the most amount of sunshine come in as well. Yep.
And then the other question is for Rutu. Just asking, are the seasonal shifts in tail biting the same across different hemispheres?
No, so in a lot of the literature from Europe, they report a lot of tail biting or increase in tail biting during their summer months, but they also have very humid summer months, so they have higher rainfall at the time, so yeah. And that's opposite to what we are seeing here.
Any thoughts on why that is?
Not a huge amount of literature on it. It's just, most of the literature is cautionary. Just watch out for this season because you might see more tail biting. So that's all there is in the literature. Yeah.
And the last question from me anyway, to you, Rutu, is on those 8 farms or 8 sites, did you see the same level of tail biting seasonally with fully ventilated, controlled environment sheds compared to blinds up and down sheds?
Yes.
You did?
Yeah.
Okay.
Yeah.
Thank you. All right. Do we have any other questions in the room?
I think we're out of time.
Do we have any other questions online?
No, we're all good. Just
Always for
congratulations.
everyone. All right, well, thank you very much indeed. I'd like everybody to thank everybody. And can you all thank all the presenters today as well, not just the last one. Okay, Lauren, over to you.
Thank
to wind it up.
So as Jeremy just said, I'd just like to take a minute to acknowledge all of our presenters. So please join me in thanking everyone. I think we can all agree that they have done a fantastic job today and their research is really, really important. So thank you very much. Can I also take a moment to thank Jeremy for hosting and seeing us on this journey? You've done a wonderful job. I thought I would also take a minute just to congratulate our students. So our honours and our master's students are graduating, and I believe at the end of this year. So well done and congratulations. And also we have, over the last 12 months, had 4 of our PhD candidates confer or complete, which is an enormous undertaking. So I would just like to quickly take this moment to acknowledge Laura Field and Natasha Williams, who have completed and conferred. and Belinda and Lee, who have recently completed and submitted and are so very close. So thank you. I'd also like to take a moment to thank our audience, both in person and online. I think it's been a fantastic audience, and we really appreciate you not only spending the day with us, but also for all of the engagement. I think it makes it such an enjoyable experience, and I've heard a number of our presenters mention how welcoming, I guess, the environment has been. So thank you very much for your time. So that just about brings us to the end. I would highlight as well that I believe we asked a question around research or sessions that you would like to see in the future. So when we come back in 2025, we will look to have a number of our animal welfare science seminars. So you can be, by all means, get back on Menti.
Nope.
Oh, it's died. It's me.
Let's
I think it's me. I need to.
Yes.
We'll go with this one instead.
Yep.
What do you want to hear about in 2025?
Hasn't updated on
Not working?
To go back. Biggest challenges trying new practices in industry. Biggest challenges of Menti.
Okay. Any different?
I think it is me.
Off you go then. Anyone from the room want to share instead?
Environmental enrichment
Excellent.
for all species.
For all species?
More chickens.
Huge philanthropic support.
Yes, excellent. Well, please do feel free, reach out and let us know. So we will have a number of seminars next year, as well as, with any luck, a final showcase as well. So before we let you all head off out, I would like to just personally thank all of the Animal Welfare Science Centre. This final showcase certainly has been a team effort, and I think it's been a really nice opportunity for you to get to meet our wider team and maybe have a bit of an understanding around why the centre is so special. So thank you very much.